Hello, grade 8 learner. Welcome again to another mathematics lesson based on the K-12 curriculum learning competency. The learner proves statements on triangle congruence. In this lesson, we will be learning how to make two-column proofs to be used in proving that two triangles are congruent. It's another great day to learn, so grab your pen, paper, and module as you start watching and learning from this video lesson. Refer to your Quarter 3 math module entitled Proving Statements on Triangle Congruence for this example. Let us write a two-column proof to prove the congruence of the following triangles given the following statements. First, we observe the figure. We mark on the figure the congruent parts that are given. We have angle E congruent to angle V. Next, we identify the triangles that we have to prove congruent. We have triangle ENR and triangle VNR. Take note of the parts that are marked on each triangle. Let us process what we know. In proving statements regarding triangle congruence, we use the two-column proof. It is a table where you list statements about the given triangles and their corresponding reasons why these statements are true. For example, in this problem, we begin our proof by writing angle E is congruent to angle V on the left column under statement. Then, under the right column, under reason, we write given. In the two-column proof, under the column for statements, we write statements which are given in the problem, observations from the figure, or implications or concepts which are suggested from the previous statements. Under the column for reason, we back up our statements through the reasons showing that the statement is true. Either the statement is given, it is an application of a property of equality, it follows the definition of the figure described, or that the previous statements prove the congruence of the triangle under the triangle congruence postulates or theorems. Thus, to help us prove the congruence of the triangles, we need to study the implications or the suggestions made by the given information. The first statement, angle E is congruent to angle V, easily shows which angles on the triangles are congruent. The second statement does not state which parts are congruent, but because segment RN is a perpendicular bisector of segment EV, we can deduce the following. As a perpendicular bisector, segment RN is perpendicular to EV, which means a 90-degree angle is formed at the intersection of the two segments. At the same time, as a perpendicular bisector, segment RN divides segment EV into two equal parts. Take note of these ideas as we start our proof. Let us solve. We begin our two-column proof by writing the given in the problem, starting with angle E is congruent to angle V, with the reason being that it is given. We mark the angles on the figures. Next, we write as the second statement the next given, segment RN is a perpendicular bisector of segment EV, with our reason being that it is given. From this statement, we are going to write our next statements. Since segment Rn is a bisector, that implies that segment En is congruent or have the same measure as segment Vn. This statement follows the definition of a segment bisector, as the statement clearly shows what a bisector does to the segment it bisects. For our fourth statement, we still look at the implications of the second statement. Since segment Rn is perpendicular to segment EV, and perpendicular lines create right angles, that means the angles at their intersection, angles ENR and VNR, are right angles. Our reason for that is based on the definition of perpendicular lines. Now, from this statement, we then write as our next statement, angle ENR is congruent to angle VNR. Because all right angles measure 90 degrees, we reason out that right angles are congruent. Checking our statements, we see that we have a pair of angles, a pair of sides, and another pair of angles that are proven congruent. In particular, the identified sides are included between the angles. This means we can now write our triangle congruence statement. Triangle ENR is congruent to triangle VNR, and support it with the reason that it satisfies the ASA congruence postulate. Let us state our conclusions. To prove the congruence of triangles ENR and VNR using the two-column proof, we were able to write the following statements and the corresponding reasons from definitions in the ASA congruence postulate, as shown by the following marked congruent parts. An alternate solution for this problem is as follows. From first to fourth statement, the proof is similar to the previous proof. For the fifth statement, from the idea that angles ENR and VNR are right angles, we can say that triangles ENR and VNR are right triangles, following the definition of right triangles. By showing that the triangles are right triangles, we can now use the right triangle congruence theorems to say that triangle ENR is congruent to triangle VNR, and through the legs and acute angles that were proven congruent, the LA congruence theorem is satisfied. Congratulations for finishing this video lesson. Now apply what you've learned by answering the activities in the activity sheet. Happy learning! We'll see you again in our next video lesson.